Hello, I'm David D. Hilster. I am a critical thinker, dissident scientist, and I'm here to tell you the truth about science. Something your university professors won't tell you, the mass media won't tell you, and certainly those science evangelists won't tell you. I am a systems person. What is that? I like to come up with systems that make life simpler. In fact, I'm a computer programmer, and I don't like programming. And I'm pretty good at programming because I don't like it. I want to make systems that make programming easier. I will do tricks all the time to write programs because I am lazy. I want to do the least amount and get the most bang out of the buck. And that's what sort of computer programming is all about. And when you take a look at systems, if I can get an interface, for instance, to have one less click than yours to do the same thing, I win. That's the kind of thing I like to do. And when I look at particle physics, it fails as a system, and it fails pretty quickly. It fails way before than you're going to imagine. I think most of you, maybe some of you who know me and can put this together before we get there, may be able to figure this out, but most of you won't, and you'll be very surprised. But let's go ahead and let's start here. Let's start at the periodic table. The periodic table is made out of elements or atoms, and there are about 103 of them you can see listed here at Wikipedia, the consensus place of the world. It's got to be, if it's in Wikipedia, it's the most agreed upon mainstream idea. It should be called mainstreamopedia because the idea is not to put new ideas in there. The idea is to put the consensus, even if it's all wrong, which there's a lot of stuff in here that's wrong. That's why we have our own Wikipedia, wiki.naturalphilosophy.org. Put your stuff in there if you have new ideas. But this is the atomic table or periodic table or the atoms that we have. And these atoms, someone said, well, we can simplify this system from 103 down to 3 particles. Let's call atoms particles. Let's call them all particles because that means they're all together, made of parts. They're all together. And what can they be made of in this case? They're made out of electrons, protons, and neutrons. And if I combine them together, and I put more of them together, for every proton and neutron, I get an electron, and I balance. Wow, it's pretty cool. I now have a system that went from 103 to 3. Right? Great. This is a great system. And remember, I told you I am going to point out the problem. This system doesn't work. We have a simpler system. My father and I already have a simpler system than this. Other people do too. Not many, very few in the world right now. Well, let's take a look at this chart. Well, there's 3 particles. Electron, proton, and neutron. Oh, what's this negative, positive stuff? Charge. Oh, charge. What is it? It's an arbitrary system. No, charge is fundamental. My goodness, without charge, we couldn't do anything. Without the system we're using, we'd have to use a different system. Guys, charge is an arbitrary attribute. Now, this is where Alexander Unziker, who I know you're watching this, I am a super fan of his. He can't take on the whole world. I mean, don't expect Alexander Unziker for you dissidents to come out and support everything you do. He's not going to support necessarily expansion tectonics. Not going to support my father's particle theory. He's fighting an amazing fight. Let him do him. It's like Bernie Sanders. He's in the middle of the Democrats and the Republicans. He's out there fighting away. He's not going to be able to do everything. So I know if you're there, Mr. Alexander Unziker, charge is arbitrary, just like as you say, as arbitrary packages with arbitrary attributes, charge is one of them. If you say it's fundamental the same way you have the universe is electric and charge is no, because we have a model that doesn't need it. So Occam's razor, we win. You talked about simplification at our conference. So, folks, we have the electron, proton, neutron. It isn't 3 particles. It's 3 particles with the beginnings of arbitrary attributes. It's got to have a magical thing called charge. So then we have a magical ability for the electron to be orbiting protons and neutrons. So there is a breakdown in the system. And yes, like I said, there are better systems that don't need this. In our model, you can throw away charge. So in our model, this line goes away. How do you do? That's all we're here to talk about. Okay, let's go further. So I'm going to look at subatomic particles, and they have the elementary particles and the composite particles. The elementary particles are considered to be particles that can't be divisible. So, okay, let's go back to the picture. Remember, we have periodic table, 103 particles. I'm going to call everything particles. Oh, now we only have 3 particles. With some magic. Charge. If this is these 2 mice, see them here, these 2 mice, one's positive, negative, they come together. Why? Don't ask. I don't know why. Or it's fundamental. Why are you asking a stupid question? Why don't you go to theater, become a thespian? Don't be you can't become a scientist. You don't know how to parrot. I'm sorry, I'm getting off here. We went again, 103 to 3 plus magic. Now what we want to do, we're going to go to quarks. Quarks 1. We went through 103 to 3 plus magic to quarks 1. There's not one. As a system, if I had a student, and let's say we didn't have any of this particle physics stuff, and I'm a systems person. Let's say I teach systems in college. And a student comes to me and says, well, you know, we've got atoms, and we've got atoms, and we have electrons, protons, and neutrons. And I have a new system. Everything's made out of one particle. I go, wow, reduction. They put a bunch of magical attributes. If you think protons, electrons, you think charge is magical, you've got quarks with magic all the way. Look at this picture, folks. This is a proton. First of all, it's a gray circle. And in that, we have little circles that look like spheres, and they got colors. I guess one's an up, another's an up, and that's the down. And then they got squiggle marks. Maybe that comes from Feynman diagrams. And that is my simplified model. The problem is if you think charge is an arbitrary attribute, start to look at, let's go to the subatomic. This is a better way to look at it. You're going to start looking up. This is the quarks. Okay, you see the quarks here. There are 3 generations of quarks, or 1, 2, and 3. 3 generations. See those numbers there, right there? Do they breed? I guess they got to come up with names, because what we want to do with our arbitrary systems that we are just absolutely inventing, we're going to give them names, me being that linguist, we're going to give it names to be poetic so that we can pontificate about it, so that you little people who can't understand these complicated systems, these symbolic systems, and manipulate the symbols on paper, even though when we look at those, we critical thinkers look at those manipulations of the symbols, oh my gosh, what do they do in their leaps? Because they do leaps and bounds between some of these equations that absolutely violate their own systems, but they don't tell you because no one understands what it all means anyways. It's an arbitrary system. So we have, remember, 103 down to 3, and now we have 6. Wait, 6? It's a quark. Why don't we call it's an atom? Everything's made of atoms. We just stop there. Let's go back to the atom. They're all atoms. Yeah. So, folks, the system, this is stupid. The system doesn't work. The idea was to get 1 quark. You went to 6, it went to 9, it went back to 6. The idea was to go to 103 to 3 to 1. That's why we named it a quark. So what happens? Well, we'll name it the quark. It sounds like, oh, wow. Well, when I teach it in school, yes, class, and my daughter's learning, these, I don't think she's got the quarks yet, but yes, class. Now, for those who go further, want to read further, that, in fact, it even gets simpler, that the electrons, protons, and neutrons are made up of 1 particle. Oh, by the way, it's got different generations, and oh, by the way, they got different masses, so it's sort of weird. How can you have a same particle with different masses? And yeah, the charge, which is already arbitrary, we're going to make it into, why not? You know, I was thinking just now, who cares if it's 2/3 charge or a third charge? It doesn't matter. It's all arbitrary. It's invented. It's wrong. So, you know, who cares? Do what you want. My goodness. And then, of course, you have the other thing is spin. And this is my father's favorite thing because, you know, spin sounds really cool because, you know, that sounds like physical. You know, maybe, hey, yeah, it spins. Okay, something spins. But we have a real big problem because if you look here, you can't see it, but you know, you can take my word for it. There's a half spin, a half spin, a half spin. They all have a half spin. Okay, that's supposedly something that is going to be real, right? Not like charge, which is arbitrary. Not like generations. What is a half a spin? And this is my father. I can't take credit for this. Half a spin. Think about it, folks, in a system. Now, if you were never to know anything about, think about it. In your mind, try to clear your mind and say, I don't know anything about particle physics, and I'm a science lover. And let's say you're teaching a class on science to some kids, whatever grade level. And the kid comes up with this and says, I've simplified it, and from 3 particles, we've gone to 1 particle. But by the way, there's 6 types of them, 6 different masses. They have charges that are different. They have spins, half a spin, and then I'm going to name them. So they're 1 quark, but we have the look, up, charm, top. I'm going to say, okay, son, obviously this is not a simplification. This is in no way, it's actually getting really complicated. Now what you are doing is simply saying, here's where quarks go wrong. This is where quarks as a system, in a very simple explanation, go wrong. You cannot take one thing and make it into a bunch of things. That's it. That's all you have to understand about quarks. It's supposed to be 1, but it ends up not to be 1. So it's not 1. So why did we do that in the first place? The only reason the quark exists is because I invented in the system that it had to be 1, because I went from 103 to 3 to 1. And I wanted to find the ultimate particle. That is where it totally gets blown apart. Because in our book, we talk about it. In our particle model, we talk about it. If you have the ultimate particle, and this is David D. Hilster, and his father speaking, but mostly me. If you have everything made out of 1 particle, it's going to have magic powers, because it's going to have to organize itself in the system. And so you're going to have to imbue it with all these arbitrary attributes. So, I mean, I can go on and on and on and on, but that's where it really blows up. And this is where Alexander Unser, I'm sure, agrees with me. The idea is there's 1 quark, and now there are 6. So we went from 103 to 3 to 6, and a bunch of other particles. So, is the system good? Absolutely not. Is the system flawed? Can be improved upon? Absolutely. Can you look at it as a systems person and say where it needs to be thrown out? And that's where Alexander Unser and I absolutely agree. Quarks on down are garbage. They were invented by somebody who wants to follow the systemic rule of 103, 3, 1. But 1 turned into 6. It then turned into 9. Oops, that's way too many. It's turned back into 6. And then we give them so many arbitrary attributes, it's laughable. So throw those out. And I'll go one further step. And that's where Alexander and I part ways. And that's fine. You know why? Because that's what critical thinkers do. Maybe someday he'll agree with me. Charge is also an arbitrary attribute. So I hope you've seen this video now as a teacher to you of what I see as a systems person and what Alexander Unziger sees as a system person and many other people. I am not the only person to think about this. Maybe I'm one of the first to put it out there and sort of organize it, but I'm not the only one. And that's one of the things I'm counting on, why this channel, I think, someday will be really important and we'll have many other people like myself out there. Why? Because critical thinking is alive and well outside the mainstream, and in my opinion, is the majority of scientists. And the majority of scientists look at particle physics and a lot of cosmology and just says, wake me up when it's real, when you got something real, because all this other stuff is mumbo jumbo. And this is why, because when you look at it as a systems, it's not good. It falls apart at the subatomic level. So remember what I say. Don't take my word on it or anybody else's on faith. Stay critical, stay thinking. I'm Dave D. Hilster. I'm your science therapist. I hope now you see why. Alexander Unziger and myself say, throw it out. Ciao for now.